Okay, let's see if the CIO can figure out this. This is always the challenge when you're talking. No, I appreciate it. Thank you, Rebecca, and really pleasure to be here in front of you all today to talk about IoT. And going to take a practical look at IoT. I've been fortunate to have worked in the IoT space now since about 2007. Currently, I'm at Industrial Scientific Corporation out of Pittsburgh, Pennsylvania. And our mission at Industrial Scientific is to end death on the job by the year 2050. And the way we're doing that is through IoT. So we're a gas detection equipment manufacturer as well as environmental health and safety software company. And for us, IoT really is going to help us go beyond and be proactive in ending death on the job. So that's really what drives us and a lot of our technical solutions. Our IoT solution, we launched it in 2004, believe it or not. So today, I'll spend a little time taking a bit of a case study approach, and I'll go deep on that. Prior to Industrial Scientific, I also spent 3 years running Pratt and Whitney, a jet engine company out of Hartford, Connecticut, their IoT solution. It was called ADEM, Advanced Diagnostics Engine Monitoring Solution. And this also a mission-critical IoT solution, capturing real-time engine data to forecast and do predictive maintenance. Not so much of a safety focus. Certainly a well-maintained engine is a safe engine. So hopefully these are two examples that I can, from personal experience, share with you and spur some thought, because it sounds like there's a lot of great innovative thinkers in this room. Let's see here. The big green button. So to get started, this maybe isn't new to people, but just wanted to kind of set a foundation for all things IoT. Clearly, I'm talking about two specific industrial IoT type of applications, but IoT we know is applicable across every industry. If there's a product or a service where capturing data can help you make proactive decisions or take action to drive value to your customers or to your company, that's an IoT opportunity. It's really just, what's the imagination that stands between us and that, right? There's just so much opportunity. When you think about agriculture, soil analysis, I know I have friends over at a company called Evaqua Technologies in Pittsburgh. They're a water filtration and water testing company. They are offering water as a service. There's just so many different ways to apply IoT. But I think one of the big takeaways is I talk to a lot of my colleagues where a lot of companies recognize IoT as an opportunity. It's not a surprise, but there's a challenge to say, how do we get off of the dime? How do we go from R&D, POC, to really driving value, getting something operational that's really checking off all the marks when it comes to being robust, being secure, being scalable. These are all, those are really the big challenges. But as you look at it, there's really two opportunities. There's an external IoT opportunity, and there's an internal IoT opportunity. And certainly externally, it's all about customer-facing value. What are the new business models that we can create and offer to our customers? Whether that's, I call it X as a service, things that I've been involved with: maintenance as a service, repair as a service, hardware as a service. But again, you can really as a service anything if you think about it. I'm waiting for the coffee as a service, right? I always seem to be that guy that runs out of coffee the morning I really need it the most, and wouldn't that be great? But the other opportunity here is recurring revenue. I know that recurring revenue for our company is extremely important. It helps a company weather the storms through different economic cycles, and as a service, IoT data starts to really let you move into that mode of saying, can we move to a subscription model? Can we create recurring revenue streams for our company to insulate ourselves from different things? And then even within recurring revenue, you have things like fixed price, pay as you go, lots of other opportunities to tailor those opportunities. Internally, if we start to take this data and point it inward into our own companies, we have an opportunity to really drive efficiencies into our manufacturing processes, certainly quality. If I think about at our company, Industrial Scientific, where we have all this equipment out there in the world sending us data back, we understand how that equipment is performing. Is it performing to spec? Can we improve our quality? Can we improve our engineering designs and things? So there's a nice quality feedback loop that you can then bring into your firm. Asset management, being able to better leverage those assets that you own all over the world and have to deal with depreciation and wear and tear. And then obviously predictive maintenance and just general forecasting. The companies, I think, that do both of these are going to be at an extreme advantage to companies that are just doing one or the other. Because if you think about it, externally, if I can create a new service for my customers, I'm growing my top line revenue, which is great. If I can bring that data inward and use it to drive efficiencies, I'm now reducing my cost base and I've got margin expansion. So that really is the goal. If you are a company, yes, you want to drive value, but if you can do it in a way where you're really pushing on those two bookends and pushing them out, you really have an opportunity to set yourself apart from others. So as I mentioned, I'm going to talk about two case studies here that are as a service. The first being Pratt and Whitney jet engines. I'm going to go light on that one because I left there in 2010. I still have colleagues there that I stay in touch with and I touched base with prior to this. And Industrial Scientific Corporation, where I've been for the last 6 years. Again, Pratt and Whitney, for those that don't know, founded in 1925. It's a leader in commercial and military jet engine design, manufacturing, aftermarket services. Industrial Scientific Corporation, we were formed in 1985, recently purchased by a larger conglomerate that's part of this program called Fortive Corporation out of Seattle. And again, we focus on safety, gas detection equipment, and environmental health and safety software. I'll go probably a little deeper on Industrial Scientific. So Pratt and Whitney, jet engine maintenance as a service. Supervisory control access data acquisition systems have been around SCADA for years, and Pratt and Whitney had been doing a lot of jet engine monitoring for a number of years. But I'd say right around 2002, started to get really serious about it and launched an IoT platform really to take advantage of the internet. And certainly from a Pratt and Whitney perspective, they had a large install base of jet engines. And frankly, I think that they were GE, Rolls-Royce, heavy competition. So they were looking for a way to differentiate themselves and provide, again, recurring revenue repair businesses and offerings that would really help them gain market share. So Pratt and Whitney really came up with 3 different programs, and these are intact today. One is called the Fleet Management Program, where they really just offer a white glove service to their airline customers around jet engine maintenance and repair. And IoT is really the foundation of that. So as planes are flying in real time, data coming off of those planes and coming into a data center and being evaluated. When I was there, this is really an interesting data point. When I was doing this in 2007, we would get 40 pieces of data at different points in the flight. So at takeoff, we'd get a snapshot of 40 pieces of data. During the cruise, depending on how long the flight was, we would get snapshots of 40 pieces of data, and then upon descent. Today, 4 million data points is what's being collected on that engine. Now, it's not all being transmitted real time, of course, but it's just staggering when I think that just in roughly 12 years, the steep hockey stick curve on the data, and think of all the challenges that come with that. But that program is alive and well and thriving today. It's really a cornerstone of their business. They also offer a couple other solutions here, engine overhaul services, which is kind of a step down from the fleet management program, and where they're giving fixed price on time and material for the engine maintenance, and then material solutions, which is really spare parts, probably fixed price on spare parts and things. But the point being, as you can see down in the lower blue block, it's all about leveraging data to optimize not only the customer experience, right? Because if I'm an airline, those engines need to be flying and doing it in a fuel-friendly way, as well as for Pratt and Whitney to continue to grow margin to service those engines in a profitable way. Get in front of lead times on supply chain, forecast when there's going to be failures so you can manage that and manage all of the spend. So that's I think hopefully just to give you some sense of the business perspective. From a technical perspective, I'm going to talk a little about some challenges and opportunities. The ADEM operational view, as I'm calling it, is pretty straightforward. You have on the plane, you have something called an electronic engine control unit, and it is transmitting data in real time through cell radio towers, satellite. That's coming into Pratt and Whitney, and then they have a suite of applications that are generating alerts based on faults, based on findings. There's actually a team of people in an operations center that are monitoring specific airlines looking for unplanned, or I shouldn't say unplanned, anomalistic type behavior that they're seeing in those engines, and recommending repair work. The opportunity really around planning and scheduling. I think that's the big one here. And this got really real for me one morning, probably, and I don't recall, that maybe 2009, where we had an airline, I won't say who we had been saying, the data is telling us you need to get this engine overhauled. You need to take it in for maintenance, major maintenance. And they says, okay, yeah, okay, we hear you. The data is screaming, you have to take this engine in for overhaul. They finally said, okay, we'll do that, and they scheduled it. Unfortunately, they had a fatality where the plane took off and crashed. It was a really unfortunate situation. It became very real for me when I got that phone call at 4 in the morning that I had to quarantine data for the FAA so that only certain people could see the data related to this incident. And it was, for me and my team, we recognize this isn't just ones and zeros. This isn't, this is very real. And the opportunity with IoT to ensure safety, to improve our lives became, again, really, really apparent to me. It made an impact, frankly, to this day, carry it forward. So what you're seeing here is, that data coming off the plane, coming into a suite of applications, and then planes that are on the tarmac, there's an opportunity where a lot of that larger data set is coming back. So I have to move quickly just due to the time here. Let's talk about Industrial Scientific. So similar to Pratt and Whitney, Industrial Scientific does gas detection as a service. So we sell handheld gas detectors that are probably not too much bigger than this. Well, they are a little bit bigger. And we have about 300,000 of these out there in the world. You can kind of see them. I'll just point here really quickly. This is kind of what the instruments look like. And they talk back to us to the tune of about 5 million messages a day are coming in from the field. And we use this data to provide just-in-time equipment to our customers. So we're monitoring the health of the device. Is it working? These devices a lot of our customer base is oil and gas, mining, petrochemical. These devices get beat up. When they come back to us, they're melted. You can't even see the screens. I mean, they're in bad shape. So they're heavy industrialized settings. So we're monitoring the sensors, we're monitoring any faults on the electrical components, and if we see any issues, we're drop shipping new equipment automatically, and that's happening, and I'll show you what that looks like in a moment. The other piece of the information that we get is the environment. What readings are the devices capturing? And then we can identify emerging problems and trends. So maybe you have a safe job site today. Methane isn't too high, hasn't hit a critical limit yet, but we can see that it's creeping up over 2 weeks. So we can generate alerts and warnings and say you have an unsafe emerging situation occurring at your plant or your facility. And then lastly, we have people information. We can tell if someone is not using this piece of equipment properly. You'd be hard. It's hard to believe, but when our devices go into alarm, a person should run, right? Get out. And often people will actually override that alarm, hit cancel, and that puts the whole operation at risk. Well, we can tell a safety director, we've got 6 people that either need to be trained or have an issue. So it's really those 3 pieces of information for us: equipment, the environment, and then the people side of it. So it's a full solution. And the way this works, and for us, I should say, Pratt and Whitney, if I just go back, Pratt's about a $19 billion company as of their 2017, 2018 annual reports. We're a smaller company, we're a $300 million company, but our iNet solutions, which is what we call it, is responsible for about half of our revenue. So about $100 million of our revenue is coming through on the back of this IoT solution we call it iNet. So the way this works, pretty straightforward. We have gas detectors, again, 300,000 of them out in the world coming in, and to the tune of about 5 million messages a day. Those 5 million messages a day get distilled down to about 200,000 alerts, and these are safety alerts that are going to safety managers at all the large oil and gas, saying you have emerging issues. Of those 200,000 alerts, about 18,000 of those alerts make their way back to Pittsburgh to our customer success team that is assigned to watch and really watch over a lot of our customers' accounts. And they're looking at additional information which triggers off action in our back office. So both Pratt and Whitney and Industrial Scientific, where the sweet spot for us is, or I think our special sauce is, not just getting the data, because the barriers to entry now for IoT are low, right? Connectivity, ubiquitous, cost to get started with AWS or Azure, pay-as-you-go models. There's nobody that can't get started in IoT. But where for us the magic is all the back office. So these alerts that come in trigger automatic orders and automatic shipments in our back office ERP systems and CRM systems. And that's where we really get scale and velocity. So of those 5 million messages come in, 200,000 alerts, 18,000 actionable alerts turns into about 5,000 drop ships of new equipment. That's all happening very, very rapidly and quickly. So our goal is to create a scalable solution that allows us to do millions of pieces of equipment without having to hire millions of people, right? The idea is, I'm not even touching on AI and things. That's a whole topic unto itself that IoT absolutely requires due to the sheer size of the data that we're collecting. But this just hopefully gives you some real world ideas as to how we're leveraging IoT and how you might as well. I think the other piece here I just want to touch on quickly is security. So cybersecurity, can't speak enough about it. This is a whole day or two workshop in and of itself. Something we take very, very seriously. Our customers expect our IoT solution that I just showed you on the prior page to be just as secure as their systems, if not more secure. So there's a couple of standards that maybe as a takeaway, maybe to think about as you're develop with security in mind. I've talked to lots of people who have created connections. They're getting data off of their equipment, but they're doing it in clear text. There's no authentication. So there's some clear standards. We actually worked with UL at Industrial Scientific. When they were forming their 2900 standard for connected devices, and there's a couple variants of it. I suggest you maybe take a look at that. And it really just kind of talks about the different aspects of security that you need to think about, how you need to test. It touches on people, process, technology, but certainly something that you have to think about from the onset, because it's hard to go back and retrofit. OWASP, really simple. This is just your top 10 web applications, making sure cross-site scripting, SQL injections, that you're testing for things like that. And then there's this ever-changing landscape of data privacy, certainly in the US and in EU, China. I'm working on some of this right now with some of our local attorneys there in Shanghai to understand what are the challenges, obstacles there with regard to data localization, data privacy, and then of course security. So it's a changing landscape, but if you really are taking these three items into your aperture and making it part of your design, you'll be in a good place. And then lastly, just to kind of maybe show you security and privacy in practice. Here's our security blueprint, if you will, at Industrial Scientific. So we have lots of different equipment. It all talks to each other, some of it through NFC, some of it through Bluetooth. We have encryption at rest on every piece of equipment, because this equipment can pick up and be taken out of a facility. So the takeaway here is your customers also have to comply. So if you're providing a service to a customer, to a Chevron, they have to comply with these rules and regulations as well. And they're only as strong as their weakest link, and you don't want to be their weakest link. So if you can demonstrate that you're proactive in security, you understand the risks, and you're getting in front of them, you'll be in a good place.